Dear students, my name is Ivana Šestak from Faculty of Agriculture, University of Zagreb, and within the module Smart Agriculture, I will shortly present one case study where we compared proximal remote sensing and remote sensing data. Investigation on estimation of soil organic matter using proximal and satellite sensors after a wildfire in Mediterranean Croatia was done for one conference, and it is a part of a doctoral study. Satellite sensors provide data to predict, classify and evaluate larger areas. But what about on the smaller plot scale? Is it possible with Sentinel data, which has special resolution of 10 or 20 meters, depending on spectral bands, we want to use? Is it possible to use it for smaller areas evaluation? Objective of this study was to assess the ability of Sentinel superspectral data in estimating post-fire soil organic matter content on a plot scale and to compare it with the results acquired with laboratory hyperspectral visible and near-infrared spectroscopy done by portable instrument but in lab conditions. The investigation was set up in a coastal part of Croatia with Mediterranean climate, and the methodology included two wildfire severity treatments, medium wildfire severity and high wildfire severity, together with control treatment, and control was part of the plot where there was no wildfire. Wildfire occurred in August 2019 and the burned area covered 15 hectares. The soil type is cambisol and samples were taken 2 days post-fire. According to these three fire severity treatments, we took 80 soil samples from depth up to 5 centimeters of the soil. Firstly, we did the wet chemistry, so we used dry combustion method to determine total carbon content in the soil, and then organic matter was subsequently calculated using conversion factor. So we got the reference data to know what the real value is. Proximal sensing was done with portable field spectroradiometer covering range up from 250 to 1050 nanometers. Two Sentinel-2 images were acquired from ESA Open Access Hub according to the closest dates field sampling and processed using SNAP ESA Sentinel application. Images were resampled to 10 meters spectral resolution and merged. Reflectance data was extracted from 80 pixels representing each georeference sample taken in the field and then also analyzed by proximal spectroradiometer. The workflow included two sources of spectral data. For both we used pre-processing methods to firstly remove noise of the spectroradiometer sensing, and we did image resampling regarding Sentinel imagery and merging. Then together with reference data we did wet chemistry with standard analysis. PLSR model was built with calibration and validation dataset and obtained the root mean squared error of calibration, root mean squared error of prediction and RPD to validate and evaluate model performance. Accuracy assessment was done according to the RPD used to compare the laboratory visible near-infrared data and Sentinel-2, but we did some model modifications. Initially, Sentinel-2 model showed very poor predictions, so the dataset was re-examined. Sampling grid was too dense, which caused the samples with known soil organic matter content to have the same spectral response because it was too dense according to the spatial resolution. So the calibration and validation dataset was trimmed both for laboratory visible near-infrared spectroscopy and for Sentinel-2. You can see the final results of the multivariate statistics with RPD and according to the categorization. Results which we got for validation of the spectral reflectance data gave us very good to excellent prediction of the model. You can see these pixels from the Sentinel-2 images covering area of 15 hectares. We had to trim the data set to cover samples with different values of the reflectance of soil organic matter. We conclude that PLSR model has a very good to excellent prediction of post-fire soil organic matter content for both spectral data and Sentinel-2. Obtained spectral data can be used for post-fire soil estimation even on a plot scale after pre-processing and pre-treatment. A good sampling grid is needed for modeling. The sampling plan has to be developed according to the spatial resolution of the image. Thank you very much.